in our as our guest lecturer today. So Dr. Kushava has done his PhD from CSR IIM. He has ample amount of industrial knowledge and he was application engineer in the Agilent Technologies. Now currently he is pursuing his postdoctoral research from the Baylor College of Medicine, one of the eminent medicinal college. And we have to always understand like metabolite profiling is very important in today's date. With ample knowledge and the depth, Dr. Kushava have done the tandem MS based metabolite profiling of 1920 epoxy cytochalasin C to reveal its importance of hydroxy group, like at the C7 position, how it is very much important for the biological activity. And with the same, like we have Dr. Kushava to speak on his all research findings on this. So, Dr. Kushava, without any further ado, I give on this to you. So, Dr. Kushava, you can start.
Thank you, Mr. Banerjee. My name is Manoj Kumar, and currently I'm working as a postdoctoral fellow in Baylor College of Medicine. So here I'm showing you some stages of my life as a true scholar. So I did my MSc from Sagar University in 2009 to 2011. After that, I joined Agilent Technology as an application engineer. So in my application engineer career, I did lots of work like a developing of MRM method, like a FDA methods, different protocol for identification of aflatoxins and different food material, plant extract profiling, PKPD analysis, all that things. So after 2014, I left Agilent and I joined project fellow for my PhD degree. So I complete my project fellow tenure in 2014 to 2015. After that, I joined PhD in mass spectrometry field, same field, and where I did the LCMS based discovery of natural product from the microbes. And my supervisor name is Dr. Ram Vishwakarma and co-supervisor Dr. Sandeep Jaglan. After completing of that, I joined IGIB as a postdoctoral fellow where I did a MRM again, MRM method that is called multiple reaction monitoring. That is a very specific for the identification of protein on triple quad instrument. After completing my tenure in IGIB, I just moved to USA for my postdoctoral fellowship program, and currently I'm working here. So I have some future goal. That's a goal, or we can say I have my personal some ethics that explore the knowledge uh, or explore the different type of mass spectrometry in the clinical diagnostic, train a good critical thinker. Uh, that's good. Nowadays, we have a very few critical thinker. We just doing the analysis and software dependent, but critical thinking is also very good character of the being a very good scientist. Support student as much as I can, always be a beggar for the knowledge and always humble and kind. And humble and kind, this is my ultimate goal. Whatever I am at any stage of life, I should be a humble and kind. So now I move on my topic. The tandem MS based metabolite profiling of 9020 epoxy cytochalasin C reveals the importance of hydroxyl group at the C7 position for the biological activity. So cytochalasins are basically polyketide compound and they are modified at the 10th number of carbon. So can you see the cursor? Hello, everyone.
Yes, Dr. Manoj, it's visible. Yes.
Okay, so at the 10th position, when this 10th position substituted by the tyrosine, it is called the perichalasin. When the indole ring comes in the substituted, that is called catabuloglucin. And when the we can say phenylalanine is substituted at that form, that is called cytochalasin. And when the alanine substitute the 10th number carbon, it's called aspochalasin. Cytochalansins are their spindle fiber inhibitor. They are very known spindle fiber inhibitor. So during my PhD in my lab, there is my colleague, Dr. Nisha Sharma. She worked on some isolation of the endophyte. See, isolate endophyte, the name is Roselinea anticruciana. It's a new endophyte that's belong to Xyluriaceae family. We scale up the culture in the lab, uh, and after that we do the semi-primitive HPLC, and simultaneously we also do the MS and MSMS. After doing the MSMS, we match these MIC value in the different database like a dictionary of natural product, and we see whether the compound present or not. If the compound are present, we only do the MS. If the compound is not present, we do the MS as well as isolate the compound as well as do the NMR for the further characterization. Because structural character, you cannot do the structure complete structure characterization based on mass spectra only. So in my PhD work, this is the isolation of the cytochelacin. This is the HPLC chromatogram of the semi-primitive HPLC chromatogram of the isolated cytochelacin. We isolated 7 cytochelacins. You can see that different peaks are eluting at the different retention time point. And these are cytochelacin P1, 9020 epoxy deacetyl cytochelacin C, 9020 cytochelacin D, 9020 epoxy cytochelacin N, 9020 epoxy cytochelacin C, cytochelacin D, and cytochelacin C. And they are the structure of cytochelacins. As you can see, they are completely structural isomer, but there is a difference of OH group extra, whether it is present in the form of peroxide or either the free OH is present. In some compound, they have an exocyclic double bond, and some compound they have epoxide, and some compound they doesn't have epoxide. Some compound they have a OH at the 90-20 position. So after the isolation of the compound, characterization of the compound, and checking the purity and everything with the all spectroscopic database, we perform the biological activity of cytochelacin. After the performing of activity of the cytochelacin cytotoxic activity with the SRV assay, we found that there is a one cytochelacin that is 90-20 epoxycytochelacin highly active on the colon cancer cell line. We observed that it's a 0.6 micromolar, that is a 658 nanomolar activity. So that's the good activity. So this is the compound that highly active on the ST colon cell line. That is surprising that why it is only affecting the ST29, that's the colon cancer cell line. So during the analysis, we found that yes, cytochelacin is specifically activated on this as well as also active on the MCF, that's the breast cancer cell line. After the activity of analysis, because they are very lone spindle fiber inhibitor, we do some fluorescent antibody tagged analysis. As you can see at the outer, that is a tubulin activity. So tubulin is a cytoskeleton of the cell, and we have an anti-tubulin antibody that is particularly bind with the fluorescent probe. As you see in the control cell where we did not treat anything, you can see the cytoskeleton is intact and the DAPIs mainly stain the nucleus. When we stain, so when we overlay the nucleus and cytoskeleton, we observe that the cell is very intact. As you can see, the cytoskeleton intact and the nucleus also intact. But when you treat with the paclitaxel, Taxol, that's isolated from the Taxol, the very known anti-cancer drug, as you see that the paclitaxel degrading the cytoskeleton as well as the very small nucleus also forms. As you see, the cytoskeleton is damaged, but nucleus also form the very small nuclei, very small nuclei. It means that they're damaging the cytoskeleton. When we treat these cells with the 1920 epoxy cytochelacin with the IC50 of that, we observe that yes, it also degrading the cytoskeleton. So here is the confirmation of that. The people is already reported more than 1,000 papers published in the cytoskeleton activity, anti-cytoskeleton activity of these compound, and these the results are very promising. We also do the electron microscopy. As you see in the control cell, you cannot see the small spheres, but when you treat the control cell with the paclitaxel, you see the very small spheres. Same effect we observe, that small sphere formed means that it damages in the cytoskeleton. So electron microscopy also confirmed that everything. So till here, all story are reported. Everything is reported. Now the story begins from here. One day I asked to our biologist, could you please provide me the culture dish with the treatment? And she agreed. She told me, Manoj, okay, today I treat the cells. After 48 hours, I will give you the Petri plate that treated with the cytochalasin C, 90-20 epoxy cytochalasin C. After 48 hours, I came into the lab and analyzed the compound with the LCMS. When I analyze the compound, I see that the cytochalasin C molecular weight is 523, so it appears as a 524 M plus H. As you see here, that the peak eluted at 19.5 retention time, it has at least 6 into 10 to the power 5 peak area, and 524 is a M plus H, and 541 is 541 is a M plus ammonium. So it means that the main compound is intact, but the one peak is appeared at 20.5. I observed that that peak has a 522 mass. At that time, that things hit my brain and see what happened with the 2 proton. Where the 2 proton gone? I know that the removal of proton is also oxidation process, but I don't know where is the oxidation happen or what happened. So now I decide to investigate what happened with the 2 proton. So I do the MSMS of the parent compound, that is 90-20 epoxycytochalasin C, and I build the tandem MS spectra of the compound. I do the MSMS and I observe that 120, 91, and M by Z 105. They appear mainly when the phenylalanine ring break down under the collision-induced dissociation at 35 electron volt. The same process I applied for the 522 M by Z, that is little late eluting in the chromatogram. I observed that 91, 105, and 120, these are the common ion fragment present. So this thing concludes that definitely it is a metabolite of the parent ion, but at that point, I didn't know that where the oxidation occurs. Then I decide to isolate the metabolite from the cell extract. I decide to isolate the metabolite from the cell extract with the full excitement. At that time, we culture the 20 T175 flask with ST20 cell line, and each flask containing 5 mg of cytochalasin. After 1 week, I realized that my experiment was failed. I literally did not get the compound that I characterized, and I realized that I wasted my 100 mg of compound. I was disappointed at that time, and this the things happens in 2016. Then I pray to God, take me under your protection, protect me, Lord. Then I take the structure and go to the chemist of my lab. There is one of the phenomenal chemists in the CSI at IIIM, Dr. P.P. Singh, Dr. Raina. I showed them the structure. Then I request them, sir, what happened with the compound? I observed that 0.5 to 1% compound that metabolized, and it giving a 522. So they told me, Manoj, there is a OH, there's a secondary alcohol, maybe it oxidized. You can try your compound to oxidize the compound with the Des-Martin reagent. So Des-Martin is a reagent that especially oxidize the compound that contain the secondary alcohol. Then this compound contain the secondary alcohol. So I oxidize the compound with the Des-Martin. I do the LCMS and MSMS, and I found that yes, it completely oxidizes. But it is a chemical oxidation. So at that time, I also afraid that the cell doing the oxidation with the enzymatically, and I'm doing the forcefully oxidation with the chemically. I don't know whether they are matching with that or not. after the oxidization of that compound, I isolate the compound, oxidized compound with the HPLC and do the NMR. I do the NMR and I observe that in the normal condition of cytochalasin C, the C7 carbon appear at the 68.5 ppm. After the oxidation, I isolate the compound and do the NMR, and I observe that the peak at 67 position disappear and it appear at the C7 position, because the keto group generally appear at more than 160 or 200 between. So I observed the previously it is a 1, 2, 3 keto groups, but when I go for the oxidized compound, I observe there's a 4 keto groups. For the confirmation of the position of the particular carbon, I perform the HMBC, and HMBC, the carbon C12 carbon, this is the 12 carbon, they correlating with that, and 8 number is correlating with 7 number, and 12 number also correlating with 7 number. So this correlation confirm that the oxidation only occurs at C7 position. So completely structural elucidation I did at that point. After that, I take the compound and perform the HPLC with the cell extract. I realized that whatever the compound I isolate and characterize by the chemical oxidation, the same compound and the same structural similarity cell oxidized by the enzyme. So that thing makes very happy. Okay, I definitely synthesize that compound, the cell synthesized by the enzyme, and I synthesized by the chemical. But here the twist comes, and what happens next? You see that I observed that previously the 90-20 epoxy cytochalasin, that is activities around 650 nanomolar. Now on the same cell line is not showing activity up to 10 micromolar. So that thinks that now the mission is accomplished, that in the cancer cell been here, that it oxidized the compound for their survival, for their survival. Now I'm moving that. What is the takeaway message of that? Completely my study. It's a very small study, but it's a very beautiful message that there is a million of so persistent behavior also related to the drug metabolite property of the cancer cell. There's a lots of hope for the DAISY, that's called recently technology where you can subtly identify the compound. DAISY and MALDI easily subtly identify the metabolite of the drug. ESI cannot able to tell where the metabolites form. Lots of tissue sample be received from the chemotherapy treated. Maybe some of you or attending student, they can try with the ESI also and try to identify whether the drugs metabolize, oxidize, reduce, dealkylation happens or not. If we look the metabolite of drug at the surface of the tissue, it provides the additional support to study the resistant behavior of the cancer cell. This is a acknowledgement for my all the members. They are from IIIM, and I published that paper in 2021, published in the ACS Omega. And after this is one of the very good case study I analyze on one of the most cytotoxic compound. Additionally, I also do the bacterial signaling system, and yeah, I published that the whole team, we can say, published the group on the ACS chemical biology, and there I identified how the bacteria communicate with each other with the LCMS-MS. And recently we also published, we identified the new cytochalasin, and I also identified some new metabolite of erythromycin in the marketed tablet. And now here is this interesting structure I show you during my PhD career. These are the peptide. They are actually not a peptide. They are called peptide bol because on the C terminus they contain CH2OH group, and N terminus it is acetylated. They produce in Trichoderma fungus. So here I just show you that how we can use the mass spectrometry in a different type of application. So here is my takeaway message. So now you can ask me the question. If you can ask any question regarding this study or whatever you think. I will try to answer all the question with my experience.
So we are open for questions.
Yes.
Any questions? So we are not having any questions from the participants. So Dr. Manoj, I wanted to ask one question.
Yes.
When you purified this compound from the culture, you did a first analytical followed by preparatory, and you did a characterization, correct?
Yes.
So Dr. Manoj, I wanted to ask, how do you optimize this kind of purification protocol when you know that your organic metabolites or the analytes is in the either in the cell culture or this kind of culture, and you need to purify it? To most of our like the participants, would you like to suggest something how to do the initial optimization and purification procedure?
Okay. So when we at the large scale culture, we perform 20 liter of culture and we extract with the ethyl acetate. So in generally ethyl acetate, the lots of organic molecule comes in the ethyl acetate. So and then we dry the ethyl acetate in the rotaevaporator. Then the whatever extract comes, we dissolve into the methanol and perform the normal HPLC on the small column, small dia column. After the seeing the chromatogram of the normal HPLC, we try to transfer that method to the semi-proprietary column and collect the peak, dry the peak, and do the MS, MSMS, and NMR and completely characterize the molecule.
Okay, thank you. Uh, Thank you, Dr. Manoj. And thanks for your wonderful lecture. Would you like to acknowledge and end it, conclude it?
Yeah, no student have any question, really?
So yeah, the question is, yes, who is asking? Please
Dr.
ask
Manoj,
question.
I have Dr. Manoj, I have a question which is not exactly related to the presentation.
Mm-hmm.
It's a general question. So you have around more than a decade of experience in the field of LC-MS, right? So
Yes.
I have just started my journey into MS. So like I'm a master student here at IIT Bombay. So around I have around 1.5 year I'm just getting into MS. So how do you suggest something like how do you define this like a decade of experience in MS? So what are the exact things which you are very proficient or which you're an expert of with respect to handling the instruments or the sample preparation or the data analysis? So how do you define this? So just out of
Yeah.
curiosity.
So uh, Devaragya Pratim. Okay.
Yes, sir.
So in the first, when you are doing the MS, one thing, 2 to 3 things you notice first, very initial, we can say first step of MS. Always know the mass of some compound, like a proton 1.007, right? Sodium 29, potassium 39. First, you see the spectra. In spectra, you realize, okay, which one is peak is M+1, M plus sodium, M plus potassium. If you go for the negative, first you observe that whether the peak is M minus H, M plus chlorine in negative form, 2M plus chlorine, like that way. So first you identify that thing. Once you are habitual with that, okay, this is my molecular ion. Then you go for the isotopic distribution pattern. The particular formula has their particular own isotopic distribution pattern. After that, When you realize these things, okay, now I understand to how to identify M by Z value or identifying the molecular ion peak. After identifying on these things, or multiple time you run HPLC and see which compound is early eluting. The compound they are early eluting, they are polar molecule, or some compound they are late eluting, they are non-polar molecule. So you separate like that. After identifying okay, polar and non-polar molecules, okay, this one is there. Then you decide, okay, what are the compound, whether they are in acid in nature and base in nature. So if the compound appear in highly negative mode, they are not appear in the positive mode. It means that they are highly acidic in the nature. They are donating the proton. That's why they are appearing in the negative mode. So now things are completed. You know the M plus H, you know their isotopic distribution pattern. You have a little bit a little bit knowledge of the polarity. Yeah, you also know the formula. Then you go for the MSMS. After the MSMS, you see the structure, draw the structure in the ChemDraw, do the manual breakdown. There are lots of tool in the ChemDraw. Then these things you practice daily. 6 months, 7 months, 8 months, 9 months. It's a long journey. And after these are few things I told you that after 6 to 8 months, you realize that you become a very good analyst. And always accept the things. For example, some people working on the triple quad, some people working on the HRMS. Triple quad have there some good benefit, like for quantification, you do the MRM. But in the HRMS, you cannot do the MRM, you do the PRM. But sensitivity wise, triple quad is good. HRMS for the quality data analysis, HRMS fantastic. So always accept the good things from the different instrument. Do not say, okay, you are working on MALDI and I have a very small instrument, so I have some limitation. No, don't judge yourself like that. You say, okay, I can also prove that same thing, but my instrument also. Because instrument just user capability define the efficiency of the instrument. If you are a very good user, if you're a good analytical chemist, you can do the same thing the people are doing on multi, you are doing on the triple quad. So these are some things that I just tell multiple time you practice and you become a very good analyst.
Okay, sir. Okay. Thank you so much, sir, for the such a detailed walkthrough which you gave. So I'll definitely try to implement this in my journey.
If you
Thank
find
you.
any difficulties in any spectra, just send me. I can help you
Sure.
how to
Sure.
interpret it.
Thank you so much, sir. Thanks.
Hi, sir.
So I would like, yeah, I would like to request, first of all, I would like to request everyone to switch on their cameras. It will be like more like a one-to-one interaction.
Yes.
Hi, sir. I have a question. First of all, thank you so much for the informative session. So I just want to know, how long did it take to complete the studies, and what are the challenges you faced, and how did you overcome those challenges?
Vijay Lakshmi, actually,
Yes.
in the mass spectrometry, you daily learn new things. Daily. You daily come to the lab, you did MS, and daily you learn the things. It's a slowly learning process. But there is some thumb rules. You have to know what is the isotopic pattern. If you have to know what is the mass of proton, if you have to know what is the molecular exact atomic weight of the C13 atom, chlorine, potassium, everything like what is the mass of oxygen. So little bit. If you very good in the periodic table, you are a good chemist. These are only things. Then you become a very good scientist. After 10 years, you say, oh, that the periodic table that published in the 12th books, that is the only chemistry.
Thank you, sir.
And like I wanted to ask one more thing. Those who are the master students, if you want to go in industry, you can ask him like what all things are required.
Yes, that is a good thing.
Yes,
So,
sir.
so if you are a master student, if you have an analytical instrument in your lab or surroundings like IR, HPLC, LCMS, NMR, So read these spectra and take the spectra. Suppose you don't know any about the mass spectra. You just go to the chemist shop, purchase any antibiotic tablet, break it in your lab, dissolve into the in the NMR tube, directly to the NMR, and take the spectra. Go to your PhD scholars who doing the NMR study or PhD scholar, and just request them, can you please help me to solve the spectra? They help you. Then when you are hunger for that, daily go to the chemist shop, take any tablet and go that, do the IR, do the GC, do the LCMS with the same compound, because everything is reported of that compound. Only that is the way when you become a very good chemist. And these things only required in the industry. Industry required HPLC, IR, MS, GC. If you are expert in that, that support you getting a job in industry. But discuss with your seniors. Don't afraid them. Just take any spectra, go to them. Sir, can you please help me to solve the spectra? They definitely solve. Then you learn, wow, that's happened. Now I have one question.
Any more questions?
I have one question to all of you. So in mass spectra, generally M plus H appears. The mass spectra appears as M plus H, right? So proton, H is a proton, right? And proton is the smallest form of the matter, right? Any matter that is we all are made up of the proton. So this proton comes from the water most of the time, or the protic solvent. So what do you think that proton comes from the water? So water become OH negative, and that proton go to the particular molecular ion. So it become M plus H. It happens, or it automatically appear. Do you think that it automatically appear on the particular ion, like a quantum tunneling? Or do you think that because if you have a water, if you dissolve some compound into the water, it become M plus H automatically, because water have a lots of proton. When you dry it up for completely water, it means that the compound molecular weight increase, but it not happens. Where the proton gone? If you see in the MS, it appears as M plus H, but you take that solution and dry it, it appears always M, not M plus H. So where proton comes and where proton gone? Either proton making us a food.
So Dr. Manoj, I would like to understand, you are telling like some sort of coupling reagent is also added, such as 0.1% Fa or TFA in that, which can act as a catalyst?
In normal water, it also happens. Like some people adding a formic acid, so the proton availability increase in the medium. But if you don't add the proton of butter, if you also put the CDCl3, it always appear M plus H. But from where the actual proton comes, I don't know, but I am just asking. That because OH negative doesn't have existence. It always having as a water.
What it is like what we have studied in the chemistry. Water is a strong, weak Lewis acid.
Yes, so the dielectric, something like that, the dielectric pole that the water has, so it imparts the charge when it is dissolved in water. And when you dry it, the water molecule reduces, so the charging is not there.
Yes, maybe because for the chemistry, I know that it comes from the water. But I really, my question is that in different way, that the particle behave in wave form and particle forms. When you see the wave, you cannot see the particle. When you see the particle, you cannot see the wave. If you put the compound in aprotic solvent, doesn't have a proton, you do the MS, you always get M plus H. From where it's come, I don't know. It's impurity. I don't know, but in ASMS, when I was with your sir, Dr. Sanjeev Srivastava, I asked this question to one of the quantum physicists. So he told me that it appears. It appears.
Sir, actually, I'm not able to understand the question quite correctly.
It's okay, but it's just for fun. So if you have any question, ask me.
So basically, you were talking about the dual nature of particles that are there.
Yes,
And
yes,
why does it happen?
yes.
I think
Just think in a different way, because there are lots of explanation for the M plus H, but nobody thinking like that way, it appears.
Everything has to deal with the compound polarity. Like when you are using whatever things we are using are hydrophobic. The column is hydrophobic. Okay, the particles which will be passing will be hydrophobic. Now you are inducing a water in a system. Okay, and gradually when hydrophilic things goes out initially, you are again inducing more of the hydrophobic solvent. Just understand, when the water is induced in such a high concentration of hydrophobic solvent, how much dipole moment, how much polarity changes induction happens. It will easily show an fluctuation which cannot be, like if you are using two solvents like solvents A and B and you are using only water, you are not likely to see any change. So that is why one of the most probably like equilibration or cleaning generally, after every equilibration or cleaning generally happens, you need to wash it with the water so that all the residuant particles needs to be washed out. So this is an interesting thing, like why water is always there. And
Yes.
yeah, so along with its dielectric constant property and the dipole moment, like it can play a very good role in everything.
Yes, yes. So that's the thing, that some things they are like ionic interaction always there, hydrogen bonding is always there, covalent ionic interaction, weak Barton force is always there. So water is always there in very little form and very few proton required for the ionization. But I'm just thinking that if you think in a different way, yes, you are right, Aragya, you are right. Your answer is right. But I'm just thinking how if we can think the same thing. Maybe I'm wrong, but let's see.
Great. It can be given in an assignment to all the participants. Like we will be also encourage means inquisitive to see their
No,
answers.
I'm just saying the
So
assignment is just understanding. I, Mhm.
yes, Dr. Manoj.
Assignment is that just go to the chemist shop, purchase any tablet, and systematically do HPLC, record the UV spectrum, do the IR, do the NMR, do the GC, and discuss with some good chemist in your lab. Even you can also discuss with Dr. Sanjeev. Then, sir, how can we solve this problem? Then it gives you a very good uh, idea how the industry works, how the quality control happens, how the drug comes in the market.
So at least this thing can be done by all of them. Like you can purchase any tablet, you will have a UV spectroscopy. It is must in every labs. Means
Yes.
every, if you don't have IR and HPLC, at least you should have an UV. Just see how their compound purity and how what peaks are coming at their desired absorption spectra.
Yes, yes, yes. You can match with the
So this
reported
can.
spectrum. Yes, that is a good homework. That is the initial step.
Sir, I
So
had a
Dr.
question.
Manoj, yeah,
Mhm.
yeah, just one thing. So Dr. Manoj, if you can unshare your slide, I would like to take a group photo of everyone with you.
Okay, so I put on the stop sharing. Okay, stop sharing. So
So everyone, please switch on your camera. We will have a group photo.
all students, they are master student.
So we have MBBS also, we have PhDs also, we have master students also, sir.
Very good, very good.
Just one more. Okay, great. You all can ask the questions.
Yes.
Sir, so what kind of data analysis softwares do you use in your lab or other people use in your lab? Are they what are available on the internet or Linux based, something like that?
That's a good question. Actually, every instrument company provide their user-friendly software. For example, if you analyze working on Thermo, they provide you Excalibur software. You can open the raw data file and transfer it to CSV file. And now in the current trend, there are lots of R script based program happens. So you can do the analysis on the R script also. If you're working on the Agilent, they provide you a bioconfirm software that is mainly for the peptide, or different like a Mascot or the Maldi, or there are lots of software available in the market. MZMine, you can really download MZMine and it can open any raw data file of any instrument. So these software. Generally, I'm using the instrument, whatever the instrument company provided the software, I am using that.
But sir, like an MSc student who wants to get into the industry after completing the MSc, they would obviously not have any experience to Excalibur or any software like this because of no access to the machines, mass spectrometry. So
Okay.
how should we approach the data analysis part without the like Excalibur software?
So Mansi, first you just develop the understanding what the spectra tell, how to read the spectra, because every company instrument have a different software. Like if you go for the Agilent, it has a different software. If you go for the water, it has a different software. If you go for Semart, it has a different software. But the understanding principle is same. So if you go in any industry, they just train you for 2 to 3 days, 5 days, and then you become a very familiar for the software. But first thing is that how to understand the spectra, what the spectra telling you. That is the important thing. If you go any company, they train you in 10 days. Then you become a very familiar for the software. The software is, you are right, the software important, but first important is that how to read the spectra, how to deal with the spectra.
Yes, sir, thank you.
So biological data interpretation is one of the most important. Like when you make what the industry says is that how do you make the sense of the data?
Yes.
Like what Manoj said, that if you get a compound and if you can characterize with the UV, like at same absorption spectra, you are getting the same peak of that compound or whatever innovator molecule, or that is a very good home. That is a very good homework, and it will not damage anything. You just take a cuvette, you dissolve your compound in that, and you take the peak of it. Once you get the peak, you can find that the compound is having a purity or not. If it is having a purity peak, then you will be deciding, okay, is there any stabilizer or any adduct molecule added in that so that the compound should stay stable, or we are getting a crude product. And everything, and believe me, everything depends upon this only. How pure is your molecule, how pure will be, means what kind of stabilizers and the adduct you give, and rest, like this kind of technique like mass spec and all those are very sensitive. But IR, UV, FTIR, then Raman, these kind of things are very easily available, and you can. It is very less time taking. It is very less time. You just go and record the data. You will get a chromatogram. Come and start interpreting the peaks. So in these cases, like what I understood, like if you have gone through the courses and also from the basic courses, every biological compounds or the biological groups will have a particular absorption spectra, where the proteins will absorb your color, where the phenyl, OH, and all these groups, where secondary proteins or the secondary particles or the secondary structure will absorb this structure, means absorb this kind of, yeah. So you can easily find it. So I think this kind of basic experience are already done. 260 by 280, 205, 190 for proteins and peptides. Very important, very basics. They will be asking you the same thing only at the industry.
It's a good.
Yes, sir.
only way to start, become a very good analyst.
So any more questions?
Good
Yes,
morning, sir.
yes, sir.
Good morning, Dr. Manoj. I wanted to ask that after your master's, you joined the industry. So, and after that, you did your PhD. So, what was the motivation for the PhD? Like, was that for upgrade in your job profile or interest?
Okay, so I just tell sometimes the financial condition also become a motivation, right? I am jobless and I didn't crack the net. 10 times I give the net, I didn't crack. So I have to find a job. And then I find the job, I find the proper job in the mass spectrometry field. So it give me a knowledge as well as me food for my family. So it became my motivation. Then I left the biological field and become a chemist because at certain point, biologists have a limitation. Because biologists see the absorption. If the absorption is less, he say, okay, compound is active. And the absorption is high, he say compound is not active. But the chemist think why it is not active. So one step beyond the chemist go. That's why I choose the chemistry. I did my MSc in biotechnology, but I facing some limitation. Why I cannot characterize this compound. Why I go to the other chemist people to ask my question to solve them. Why I did not try. I decide, okay, then I left the complete biology. I become a interdisciplinary at that time. I joined Agilent and I learned an NMR. Then I applied my 2 years knowledge on my PhD, and it was phenomenal experience. And you realize if you are a good biologist and good chemist, you become a very good scientist. No one can beat you. They are a very rare combination.
That's all. Thank you so much, sir.
Okay, if no more questions are there, thank you, Dr. Manoj, for your wonderful time and the lectures. And in case of any doubts, like you can directly post your questions, we will be getting it answered from Dr. Manoj. Thank you, Dr. Manoj.
Thank you. Thank you very much, all of you. You are such a enthusiastic children. Very good. Very good. I want to see you in a very good, in future, very good scientist. Thank you very much. If you ask any question, just mail me. I will try to answer any mass spectrometry related question. Thank you very much, sir, for inviting me or giving me providing me opportunity to give the lecture of some young, powerful, energetic guys. Thank you very much.
Thank you, Dr.
Thank you.
Manoj.
Thank you.
So, yeah, so now we are open for the script session, but surprisingly, nobody have entered their doubts only. I hope there is no doubts in week one as well as the week one module as well as the advanced module. Nobody means as nobody has entered their doubts. But we do have time. If anybody wants to ask any questions, we can take few. Yes, Sanasia, please go ahead.
So actually, I had a doubt. It was in the video sample prep, which was by John Wilson. So one of the slides had that he had like measured the BSA response with digestion buffer and with S-trap and digestion buffer. So my question was that when you compare both the experiments, in one the sampling was n is equal to 8 and the other was n is equal to 3. So is it okay for comparison? Because we are normally taught that both the things have to be same.
Okay, let me break by break part this question. Why are you doing digestion? You will only give me the answer.
Why
Why
are we
are you
doing digestion?
why are you
To
doing
break
the
the
digestion?
proteins.
Yes.
To break the
No.
proteins.
So the thing is that you want to prepare a lysate. First
Yeah.
thing you have to go sequentially. First you are taking the samples to prepare the lysates. From the lysates you extract the crude proteins and the metabolites. Okay. Why we are using S-trap? In the S-trap, the protein molecules get attached and every other impurities and every other things gets filtered out.
Yes,
Correct? So
correct.
now you have proteins with it and a simple comparison with or without estrap. There will be a comparison with and without estrap.
Yes,
So
yes.
the estrap shows it has a maximum efficiency. Okay, maximum efficiency, that more number of proteins can be digested in the peptides. The recovery efficiency is more. But what is your end question? Irrespective of the sample size, I will come at the sample size respect. What is your end point? You are getting the peptides. Okay, whichever way you follow, you want to get a peptides that is
Efficiency is
injectable into the mass spec. Hello, yes, Sana. We lost Sana.
yes, sir.
Hello. Yeah, yeah.
No, no,
So
I
you
think
just
your
require.
voice just cracked a bit in me.
Okay.
That is to know the efficiency with and without extract.
Just a minute.
He's joining again. Just wait.
Okay, so now what I was telling, like you have the efficiency coming to the efficiency in terms of recovery rate as well as the amount of the peptides. So when you use a S trap, you get a greater efficiency of recovery, okay, rather than when you do in hand kind of things. But you have to do a cost comparison or a cost comparison parameters during the experiment. Though S trap is very simple, you will get the things in one day, but the product S trap is a bit costly, irrespective of whether how many samples you use. But you always remember what is the end product. End product is you want to get a clear peptides which is quantifiable that can be injected in the mass spec. If your focus, you can do any method, you can practice any method you want. So BSA three samples, two samples, five samples, it shouldn't expect means affect your means this kind of experiment. Only the thing is that whether you use a batch one and batch two, five each, then it will be a equal batch. And if you are not doing a similar number of samples or the similar number of A, the group variance will be different.
Yeah, so
At
something
the
like
end.
that only I was coming to, like it will show some variance, right? Because in one you are using it and
Variance.
the other you are not using it. So isn't
No,
it?
no. So variance is not important. You want to understand like what question you are answering here. If you use if you use means one method with the strap and one method with the preomics kit, okay, you do a discovery study, okay, you see you get 5,000 proteins identified from strap and you get 5,100 proteins more from preomics kit. Okay, so when you do a endpoint tally, like you just do a Venn diagram and match how many proteins are there, you will be finding 90% of the proteins will be matching with each other.
Okay, so the sampling size doesn't matter in such cases.
Sampling size matters for confidence, for gaining the confidence. If you at least run 10 samples, if you compare 10 samples with the 10 samples, then you can tell, okay, my sample size is. But if you run just only one sample and you tell that, okay, I have got this all in my sample, the next sample there might be much more and might be much less depending upon your biological memory of your hand, how you are operating the things.
Okay. Okay, got it. Thank you, sir.
Any more questions? Dr. Shivalakshmi, today no question. Ina, do you want to ask any question? Mansi, are you planning to buy some medicines from the market? By the way, we have one small ATR FTR also in the lab. If you want to get some spectra, you can get it. That kind of running spectra. Okay,
But
some
I
pure
will
bio.
definitely try once my college restarts because now we have our exams from 18th till 22nd. So after that, 1 month holidays there, and from August our college will start. So I will definitely try this then.
Sure, sure. Any more questions? Okay, so if not, as we most of us know each other, you can interact in the group also. So if there is no more questions, your quiz marks will be released today only. Assignments will be given. Do see that a confirmation mail comes after the assignment submission. And yeah, and if there is no further questions, then have a happy weekend. Yes, Sana.
So the previous assignments, we were planning to discuss those if we can know where we are going wrong.
Yeah, so you can let me a day like which assignment, assignment one or assignment two or assignment
I
three you
think,
want to discuss.
yeah, I'll also check, and if there's some
Sure, sure,
particular thing, I'll let you know, because we
sure, sure.
don't know in the, like how we have in the quiz, we know what is the right wrong answer, but in the assignment we don't know which is the
So
wrong
that is
answer that
for for that is only like we are having this script session, but nobody entered any script only. I thought everybody understood everything. We could have
no
taken some assignment questions today. We had
no
lot
no
of time.
uh, no, but actually we don't know what are our wrong answers. No, like a quiz, we have not received the Google form where we know what is the wrong answer for a assignment. So
So
if we come to
maybe
know that, we can,
maybe one thing can be done.
try
A
again and
solve
then come back.
So a solved question of assignments, like a solution assignment with common, a general template can be circulated to all. Let them go through it, and after that we can take their questions on the priority. This
Yeah,
thing
so we
can be
can
done.
try again. Like when we get to know the wrong answer, probably we'll try again. And if we have any issue, we can then discuss it.
Okay, that can be done. Yes, Dr. Vijay Lakshmi.
Sir, I have a small request. Sir, is it possible to have an hands-on session on Metascape and other pathway
That
analysis?
that will be done easily, but you are going beyond. Means now you catch the basics things. We will teach you everything. We will have a Metascape. Already you have done Reactome, correct? Already you have done Reactome. Now you can play with the Reactome. So Metascape and all those things will come at a later stage.
Okay.
How to beautify your final diagrams. But the biological, just understand gene ontology thing. If you understand what is the biological processes happening, what is the molecular function happening, and what are the cellular components, function, process, and component. If you understand three things, you know everything about that particular protein.
Okay, sir, is it possible to elaborate a bit more on gene ontology and all in coming days? Like, is it possible?
Yeah, I can take one or two lectures and I can see like how I can do a best fit of it.
Yeah. Gene ontology, gene set enrichment analysis. Like sometimes I get confused. So,
Yeah, so yeah, gene set enrichment analysis and gene ontology. Yeah, sure. That is ORA, overall representation analysis.
okay, okay, sir. Thank you.
So, okay then, have a happy weekend. Enjoy your time. So, today we have more time than other days. So, enjoy your time. Have a happy weekend. Chalo. Thank you all for joining.
Thank you, sir.
I'm Nick.
Thank you, sir. Bye, sir.
Chinmay.